And now in this lecture we'll answer two questions. In the first question, we'll find out the size of this angle ABC is equal to x. We have to find out the value of x. And in the second question, we will find out the length of this line segment AD is equal to x. Again, we have to find out the value of x. So we start with the first question. In the drawing, we have quadrilateral ABCD. Those two angles are both equal to 80 degrees in their sizes. And we also know that BC equals to BA equals to AD. And our task is to find out the size of this angle ABC is equal to x. We have to find out the size of this angle x. So in the first step, we will join points B and D together by a straight line. By joining points B and D, we divided this quadrilateral ABCD into triangles. The first triangle is triangle BCD, and the second triangle is this triangle BDA. So this triangle BDA, those two sides are equal to each other. So if we define the side of the length of this side ADSA, then the length of this side BA must be also equal to A because they are equal to each other. Likewise, BC equals to BA equals to AD, so BC will be also equal to A. According to what is given the question, all those three sides are equal to each other, therefore each of them must be equal to A. And we have the rule that says that in front of equal sides in the triangle there are equal angles. Again, in front of equal sides in the triangle there are equal angles. So in this triangle BAD, in front of those two equal sides, we have those two angles that must be also equal to each other in their sizes. So if we define the size of this, again, in front of those two equal sides, we have those two angles that must be equal to each other in their sizes. So if we define the size of this angle as alpha, then the size of this angle must be also equal to alpha because they are equal to each other. You know that the sum of the angles in any triangle is equal to 180 degrees. So the sum of the angles in triangle ABD must be equal to 180 degrees. So which angles we have in triangle ABD? We have alpha plus alpha is 2 alpha plus 80 degrees. In total it must be equal to 180 degrees according to the rule dimension. So in triangle ABD, the sum of the angles must be equal to 180 degrees. So 2 alpha plus 80 degrees in total must be equal to 180 degrees. And again, in this line ABD, 2 alpha plus 80 degrees must be equal to 180 degrees. Here we subtract 80 degrees from this equation. And we will get that 2 alpha equals to 180 degrees minus 80 degrees is 100 degrees. So 2 alpha equals to 100 degrees. Here we will divide this equation by 2. If we get that the missing angle alpha equals to 100 degrees over 2 is 50 degrees. Those two angles are both equal to alpha, so each of them is equal to 50 degrees in its size. So, what is the size of this missing angle? Angle CDB. Again, what is the size of this missing angle? Angle CDB. Angle CDB equals to 80 degrees, the big angle, minus this angle, this is 50 degrees. 80 degrees minus 50 degrees is 30 degrees. So angle CDB equals to 30 degrees in its size. In the next step, we will define this angle BCD, this big angle BCD as beta. And we will implement the law of sines, this triangle ABD. But again, we will implement the law of sines in this triangle ABD. So, open quickly on the law of sines. This is triangle ABC, that could be any triangle. The length of side AB is C units, side AC equals to B units in its length, and side BC equals to A units in its length. The size of this angle BAC is capital A degrees. The size of this angle ACB is equals to capital C degrees. And the size of this angle ABC equals to capital B degrees. So, this triangle ABC that could be any triangle. According to the law of sines, the following equation is to A over sinus A equals to B over sinus B equals to C over sinus C. Again, capital A, capital B, and capital C are the sizes of those three angles inside triangle ABC. Repeat again, this triangle ABC that could be any triangle. A over sinus A equals to B over sinus B equals to C over sinus C. So we can implement the law of sines in our drawing. And again, we implement the law of sines in this triangle ABD. In triangle ABD, according to the law of sines, BD over sinus 80 degrees equals to AB over sinus 50 degrees. Repeat again, this line ABD, according to the law of sines, BD over sinus 80 degrees equals to AB over sinus 50 degrees. BD is the missing side, so we leave it as it is BD. Or sinus 80 degrees. We will substitute 80 degrees by 2 times 40 degrees. Okay, again? We will substitute 80 degrees by 2 times 40 degrees, and therefore sinus 80 degrees is sinus 2 times 40 degrees. And it is equal to AB. AB is A according to our definition, so we'll substitute AB by A, or sinus 50 degrees. We will substitute 50 degrees by 90 degrees minus 40 degrees. Again, we substitute 50 degrees by 90 degrees minus 40 degrees. So sinus 50 degrees is equal to sinus 90 degrees minus 40 degrees. So in total, we have found out that according to the law of sines, BD over sinus 2 times 40 degrees equals to A over sinus 90 degrees minus 40 degrees. We have here two trigonometric identities. The first trigonometric identity is as follows: sinus 2 alpha equals to 2 times sinus alpha cosine alpha. This is the first trigonometric identity. And we're using this equation another trigonometric identity. The trigonometric identity is as follows: sinus 90 degrees minus alpha equals to cosine alpha. See it again. The trigonometric identity says that sinus 90 degrees minus alpha equals to cosine alpha. This is the second trigonometric identity that we use in our equation. So in our equation we have BD over sinus 2 times 40 degrees. According to this trigonometric identity, sinus 2 times 40 degrees equals to 2 times 40 degrees times cosine 40 degrees. Repeat again. According to this trigonometric identity, sinus 2 times 40 degrees equals to 2 times sinus 40 degrees times cosine 40 degrees. This is 2 times sinus 40 degrees times cosine 40 degrees, and it is equal to A over sinus 90 degrees minus 40 degrees. According to this trigonometric identity, sinus 90 degrees minus alpha equals to cosine alpha. We will get that sinus 90 degrees minus 40 degrees equals to cosine 40 degrees. Repeat again. According to this trigonometric identity, we will get that sinus 90 degrees minus 40 degrees equals to cosine 40 degrees. So in total, we should find out that BD over 2 times sinus 40 degrees times cosine 40 degrees equals to A over cosine 40 degrees. Here we have cosine 40 degrees on both sides of this equation, so cosine 40 degrees will get cancelled. So we cancel cosine 40 degrees. In this side of the equation we left only with A, while on the other side of the equation we have BD over 2 times sinus 40 degrees. So to that we found out that A equals to BD over 2 times sinus 40 degrees. Repeat again. For another 3. that A equals to BD over 2 times sinus 40 degrees. Here we will multiply this equation by 2 times sinus 40 degrees. And we will get that BD, the left of the missing side BD, is equal to 2A times sinus 40 degrees. Repeat again, we found out that this is the missing side BD is equal to 2A times sinus 40 degrees in its length. So write it now. BD equals to 2A times sinus 40 degrees in its length. In the next step, we will implement the law of sines. This red triangle BCD. But again, we will implement the law of sines in this green triangle BCD. So, in triangle BCD, according to the law of sines, the following equation is true. BD over sinus beta equals to BC over sinus 30 degrees. And again, according to the law of sines, this green triangle BCD, the following equation is true. BD over sinus beta equals to BC over sinus 30 degrees. We already found out that BD equals to 2A sinus 40 degrees, therefore we solve the BD this equation by 2A times sinus 40 degrees. Over sinus beta and it equals to BC. BC equals to A units in its length according to our definition. So we substitute BC by A over sinus 30 degrees. Sinus 30 degrees is 1/2. So we substitute sinus 30 degrees by 1/2. And A over 1/2 is 2A. Again, A over 1/2 is 2A. So in total, she found out that 2A times sinus 40 degrees over sinus beta equals to 2A. Here we will multiply this equation by sinus beta and we get that 2A times sinus 40 degrees equals to 2A times sinus beta. Equals to 2A times sinus beta. Here we have 2A on both sides of this equation, so 2A will get cancelled. After we cancel 2A, this side of the equation we have to with sinus 40 degrees equals to sinus beta. So repeat again, if we found out that sinus 40 degrees equals to sinus beta. if sinus 40 degrees equals to sinus beta, it means that beta equals to 40 degrees. Again, if sinus 40 degrees equals to sinus beta, it means that beta equals to 40 degrees. In size, that is the first solution for beta. But we have another trigonometric identity that says that sinus alpha equals to sinus 180 degrees minus alpha. So according to this trigonometric identity, we will get that sinus 40 degrees equals to sinus 180 degrees minus 40 degrees. And 180 degrees minus 40 degrees is 140 degrees. So it is sinus 140 degrees. So those two sides of the equation are equal to each other. That is to say, we should find out that sinus 40 degrees equals to sinus 140 degrees. Okay, sinus 40 degrees equals to sinus 140 degrees. So we can add here that sinus 40 degrees equals to sinus 140 degrees. According to what we already found out here. So sinus 40 degrees equals to sinus 140 degrees. So what we did, we can find out that sinus 40 degrees equals to sinus 140 degrees, and is equals to sinus beta. So to that, we should find out that sinus 140 degrees equals to sinus 40 degrees equals to sinus beta. Those two sides of the equation are equal to each other. That is to say, sinus 140 degrees equals to sinus beta. If sinus 140 degrees equals to sinus beta, it means that beta equals to 140 degrees in size. This is the second solution for beta. But according to the first solution for beta, beta equals to 40 degrees in size. Angle beta. So we have two solutions for the value for the size of angle beta. Angle beta equals to either 40 degrees or to 140 degrees in size. But if we look on the drawing here, this is angle BCD is equal to beta. Angle BCD is definitely greater than 90 degrees. Again, this is angle BCD that is definitely greater than 90 degrees. And if angle BCD is equal to beta is greater than 90 degrees, beta can never be equal to 40 degrees. Beta can never be equal to 40 degrees, that is less than 90 degrees. So the first solution for beta equals to 40 degrees is equal solution according to the norm. So we will take into account only the second solution for beta. That actually beta equals to 140 degrees in its size. We know that the sum of the angles in any triangle equals to 180 degrees, and the sum of the angles in triangle BCD must be equal to 180 degrees. So which angles we have in this triangle BCD? And beta equals to 140 degrees in its size. So in this triangle BCD, we have 40 degrees plus 30 degrees plus 140 degrees. Plus this BC angle, the actual angle DBC. The sum of those figures must be equal to 180 degrees. Repeat again. In the green triangle DBC, the sum of the degrees must be equal to 180 degrees. That is to say, 30 degrees plus 140 degrees plus the DBC in total must be equal to 180 degrees. 30 degrees plus 140 degrees is 170 degrees. So 170 degrees plus the first missing angle, the angle DBC, in total must be equal to 180 degrees. Here we subtract 170 degrees from this equation, and we get that the missing angle DBC is equal to 180 degrees minus 170 degrees is 10 degrees. So if you found out that this is the missing angle DBC, it is equal to 10 degrees in its size. Again, our task is to find out the size of this angle ABC is equal to x. Again, our task is to find out the size of this angle ABC is equal to x. Angle ABC in total equals to 50 degrees plus 10 degrees, that is 60 degrees. So if you found out that the missing angle x equals to 60 degrees in its size, or angle ABC equals to x is equal to 60 degrees in its size. This is angle ABC is equal to x, and it's equals to 60 degrees in its size. So we finish with the first question. In the next step, I'll present you the second question, and we will solve the second question by using two different methods. In this second question, our task is to find out the length of side AD. This side AD is equal to x. So we have to find out the value of x. So in the domain we have quadrilateral ABCD. Those two angles are both right angles. This is the short line segment DP is equals to 1 unit in itself. This is line segment PC is equals to 4 units in itself. Again, our task is to find out the length of side AD is equal to x. We have to find out the value of x. So in the first step, we will join points B and D together by a straight line. By joining points B and D, we divided this quadrilateral ABCD into two triangles. The first upper right triangle ABD and the second lower right triangle BCD. So we will implement the Pythagoras theorem on both those two right triangles. According to the Pythagoras theorem, in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So first of all, we will implement the Pythagoras theorem on this upper right triangle ABD. Here by PT is the relation for Pythagoras theorem. According to the product theorem, in this upper right triangle ABD, BD squared, that is the score of the hypotenuse, equals to AB squared plus AD squared. AD is the line segment that we're looking for in this question. So plus AD squared. So in total, according to the product theorem, in this upper right triangle ABD, dB squared, that is the score of the hypotenuse, equals to AB squared plus AD squared. The hypotenuse BD is the missing side, so leave it as it is. It is BD squared equals to AB squared. AB is also the missing side, so leave it as it is. Here we know that AB equals to BP. Again, AB equals to BP in its length. According to what is given in the question, side AB equals to side BP. So both sides are unknown, so we leave it as we leave AB as it is. So it is AB squared plus AD squared. AD is the line segment that we are looking for, so it equals to x. Therefore, if AD equals to x, it means that AD squared equals to x squared. So in total, according to equation 1, we found out that BD squared, that is the square of the hypotenuse, equals to AB squared plus x squared. Likewise, we will implement the product theorem of this lower right triangle BCD. Here by PT is the promotion for product theorem. This lower right triangle BCD, BD squared, that is the square of the hypotenuse, equals to BC squared plus DC squared. And again, it's right lower triangle BCD, according to the product theorem, BD squared, that is the square of the hypotenuse, equals to BC squared plus DC squared. According to what is given as the question, DC total equals to 1 plus 4, that is 5. So, write it down. DC equals to 5 units in its length. According to what is given as the question. So in total, according to equation 2, we found out that BD squared equals to BC squared plus DC squared. BD is the missing hypotenuse, so we leave it as it is. This is BD squared equals to BC squared. So we don't know the value of BC, so we leave it as it is. It's BC squared plus DC squared. DC is 5, therefore DC squared is 5 squared, that is 25. So in total, according to equation 2, we found out that BD squared equals to BC squared plus 25. This is according to equation 2, while according to equation 1, we found out that BD squared equals to AB squared plus X squared. So we have two different equations for DB. Therefore, we get equation 3 that says that BD squared according to equation 1 must be equal to BD squared according to equation 2. BD squared according to equation 1 equals to AB squared plus X squared, and it must be equal to BD squared according to equation 2. BD squared according to equation 2 equals to BC squared plus 25. Repeat again that according to what is given as your question, AB equals to BP. AB equals to BP. Because of the fact that AB equals to BP, can substitute AB in equation 3 by BP. But before that, we will implement the balance theorem on this tile PBC. Again, we will implement the balance theorem on this right green tile BCD. This will be equation 4. This green right tile BCD, green lower right tile BCD, here by PT is a version for balance theorem. So this green right tile BCD according to the balance theorem, BP squared, that is the square of the hypotenuse, is equal to BC squared plus PC squared. And again, this green right triangle BCP, according to the balance theorem, the following equation is true. BP squared, that is the square of the hypotenuse, equals to BC squared plus PC squared. Repeat again, we only found out, according to what is given as equation, AB equals to BP. Therefore, we can substitute BP in this equation 4 by AB, because AB equals to BP according to what is given as equation. We do it now, we get that AB equals to BP, and so BP squared equals to AB squared, according to this equation 4, and AB squared equals to BC squared plus PC squared. But here PC is 4, therefore PC squared is 4 squared, that is 16. So in total, we actually found out that according to equation 4, AB squared equals to BC squared plus 16. Again, according to equation 4, AB squared equals to BC squared plus 16. This is according to equation 4, but according to equation 3, we actually found out that AB squared plus X squared equals to BC squared plus 25. According to equation 3, we already found out that AB squared plus X squared equals to BC squared plus 25. So you can substitute ab squared in this equation 3 by the value of ab squared according to equation 4. Ab squared equals to bc squared plus 16. So we substitute ab squared in this equation 3 by bc squared plus 16 from equation 4. When we do it now, we get that again ab squared equals to bc squared plus 16. And we also here plus x squared equals to bc squared plus 25. So in total, according to equation 3, we actually found out that bc squared plus 16 plus x squared equals to bc squared plus 25. So here we have bc squared on both sides of this equation, so bc squared will get cancelled. After cancelling bc squared, on this side of the equation 3 we left only with 16 plus x squared, while on the other side of this equation 3 we left with only 25. So total we found out that 16 plus x squared equals to 25. Here we will subtract 16 from this equation 3. And we get that according to equation 3, x squared equals to 25 plus 16 is 9. So x squared equals to 9. Here we take root out of this equation, and we get that the square root of 9 is 3. So x equals to 3 units in this length. So we should put down that the length of this side AD is equals to x is equals to 3 units in this length. AD equals to x and x equals to 3 units in this length. So we finish with the first method. The next step I will present to you how to find out the length of this side AD is equals to x according to the second method. The second method, we will do a construction. That is to say, we will extend this side DC by 4 units. Again, we will extend side DC of quadrilateral ABCD by 4 units. And we will define the edge of the extended line segment. This point is point Q. Again, CQ equals to 4 units in this length according to our construction. Repeat again. CQ equals to 4 units in this length according to our construction. In the next step, we will join points B and Q together by straight line. So we extended the straight line DC by straight line. When we extend the straight line by straight line, the result DQ must be also a straight line. Okay? DQ is the straight line, and according to rule 3, the sum of the angles on one side of a straight line is equal to 180 degrees. Again, according to rule 3, the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of the straight line DQ at point C? We have this angle is equal to 9 degrees, according to what is given in this equation, plus this missing angle. Total the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to 9 degrees in its size. In the next step, we prove that those two right angles can point to each other according to side angle side rule. That is to say, we prove that this right angle BPC can point to this right angle BCQ according to side angle side rule. So we have to prove that this right angle PBC can point to this right angle BCQ according to side angle side rule. And again, we have to prove that the right angle PBC can point to the right angle BCQ according to side angle side rule. So why those two right angles converge to each other? First of all, PC equals to CQ equals to 4 according to our construction. Again, PC equals to CQ equals to 4 according to our construction. So put it down. PC equals to CQ equals to 4. So if it again, we should find out that side PC with the right angle PBC equals to side Q to side CQ with the right angle BCQ. They are both equal to 4, and therefore they are equal to each other according to our construction. In addition, those two angles are both right angles, and therefore they are equal to each other in their sizes. So this is again BCD. BCP, this is again BCP. Is the right angle BCP, and it equals to this angle, this is actually angle BCQ. The right angle BCQ. Okay, again, we should find out that angle BCP in the right angle PBC equals to angle BCQ in the right angle BCQ. They are both equal to 90 degrees, and therefore they are equal to each other. And finally, BC is a common side that belongs to both angles, so we can write down that BC equals to itself as a common side that belongs to both angles. So we can prove that the right angle PBC can point, this is the side can point to the right angle BCQ according to side angle side rule. This is to say, we should prove that those two sides and the angle that is included between those two sides, that is the right angle, it is right angle BCP corresponding equal to those two sides, and the angle that is included between those two sides is also a right angle. This right angle BCQ. Therefore, those two right angles can point to each other according to side angle side rule. We have those two sides and the angle that is included between those two sides in this right angle BCP corresponding equal to those two sides, and the angle that is included between those two sides in this right angle BCQ. Therefore, those two right angles can point to each other according to side angle side rule. And for the fact that those two right angles converge to each other, we derive that those two corresponding sides must be also equal to each other in their lengths. So BP equals to BQ. Repeat again. Side BP in the right angle PBC equals to side BQ in the right angle BCQ, according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, and therefore those two corresponding sides must be also equal to each other in their lengths. So side BQ equals to side BP. But according to what is given as the question, we know that AB equals to BP. AB equals to BP. AB equals to BP. So if you found out that those three line segments AB, BP, and BQ, they are equal to each other. So let it down, if you found out that side AB equals to side BP according to what is given as the question, and because of the fact that BQ equals to BP, it means that BQ equals to BP equals to BA. Okay, again, so now that the three sides AB, BP, and BQ, they are equal to each other in their lengths. In the next step, we will do a construction. This is to say, we will draw a circle around point B in such a way that point B will be the center of the circle and AB will be the radius of this circle. And again, we will draw a circle around point B in such a way that point B will be the center of the circle and the radius of this circle will be BA. And because of the fact that AB equals to BP equals to BQ, AB equals to BP equals to BQ, AB is the radius of the circle, and therefore BP is also the radius of the circle, and BQ is also the radius of the circle. So we define the radius of this circle as R. So AB is the radius of this circle. This equals to R according to our construction. And BP is also the radius of the circle. This equals to R. And BQ is also the radius of the circle. This equals to R. And because of the fact that AB, BP, and BQ are all the radii of the circle, it means that the circle must pass through those 3 points A, P, and Q. And again, because of the fact that AB, BP, and BQ, they are all the radii of the circle, it means that the circle must pass through the radii of this circle. This is to say, it must pass for A, for point P, and for point Q. You can see the drawing that indeed the circle passes for points A, P, and Q. So this gives us the question that DA is perpendicular to AB. Again, DA is perpendicular to AB according to what is given as the question. But because of the fact that AB is the radius of the circle, it means that DA must be the tangent to this circle at point A. Okay, then we know that according to what is given as question, side DA is perpendicular to side AB. DA for that to AB according to what is given as the question, but AB is the radius of the circle. AB is the radius of the circle, and therefore DA is the tangent to this circle at point A. Again, DA must be the tangent of this circle at point A. So DA is the tangent to the circle. We focus on this convex arm point D. From the convex arm point D, we have tangent DA that is tangent to the circle at point A. Likewise, from the same convex arm point D, we have secant DQ. Secant DQ cuts the circle to points P and Q. So DP is the external part of secant DQ. This is the external part DP secant DQ. And in total, the secant is DQ. The length of the secant is DQ, and DP is the external part of the secant DQ. Actually, all the requirements of tangent secant theorem are satisfied, and therefore can implement your tangent secant theorem on this convex arm point D. So, basically on tangent secant theorem. According to tangent secant theorem, if a tangent and the secant are drawn to a circle from the same external point P, this is the convex arm point P. From the convex arm point P, we have tangent PA, that is tangent to the secant point A. Likewise, we have secant PC. Secant PC cuts the secant points, 2 points B and C. And the external part of secant PC is PB, and in total the length of the secant is PC. And the external part of secant PC is PB. So, if a tangent and a secant are drawn to a circle from the same external point P, the score of the tangent length equals to the product of the secant's all length and its external part. So, according to tangent secant theorem, in our domain, we get that the length of the secant, the length of the tangent square, that is PA square, equals to the product of the external part of secant PC, that is PB times PC. Again, PA square equals to PB times PC. Okay. So we can actually implement tangent secant theorem in our domain. If we focus on the convex arm point D, from the convex arm point D, we have tangent DA, this is tangent to the secant point A. Likewise, we have secant DQ, that cuts the circle 2 points P and Q. DP is the external part of secant DQ, and total the secant equals to DQ. So according to tangent secant theorem, the following equation is true. dA square equals to dP times dQ. Again, dA square equals to dP times dQ. So, the convex arm point D, we represent the tangent secant theorem. According to the tangent secant theorem, dA square, that is the length of the tangent squared, equals to dp times dq. dp is the external part of dq, so the product of the external part dp by dq equals to dA squared. Repeat again. According to tangent secant theorem, if we focus on the convex point D, the following equation is so: dA squared, that is the length of the tangent squared, equals to dp times dq. dp is the external part of secant dq, and dq is the length of the secant. The product of the external part times the secant equals to dA squared, according to tangent secant theorem. dA equals to x, and therefore dA squared equals to x squared, and it equals to dp times dq. dp is 1 times dq. dq in total equals to 1 plus 4 plus 4, that is 9 again. dq in total equals to 1 plus 4 plus 4, that is 9. So in total, we found out that x squared equals to 1 times 9, that is 9. X squared equals to 9. Here we take out of this equation and find that x equals to the square root of 9, that is 3. So side AD equals to x equal to 3 units in its length. So on both methods, we found out that the length of side AD equals to x is equal to 3 units. So we finish with the second method. The next step summarizes the lecture. That is to say, we repeat on the solution of the first question, and then we repeat on the solution of this second question on both methods of this second question. In the first question, this is the first question, our task was to find out the size of this angle ABC is equal to x. We have to find out the value of x. So in the drawing, we have quadrilateral ABCD. Those two angles are both equal to 80 degrees in their sizes. We know that BA equals to AD. Again, our task is to find out the size of this angle ABC is equal to x. We have to find out the value of angle x. So, first of all, We join points B and D together by a straight line. By joining points B and D, we divided quadrilateral ABCD into triangles. And in the next step, we focus on this triangle ABD. On this triangle ABD, we have the rule that says that in front of equal sides in the triangle, there are equal angles. Yet in front of equal sides in the triangle, there are equal angles. So in front of those two equal sides, we have those two angles that must be also equal to each other and their sizes. So if we define the size of this angle as alpha, then the size of this angle must be also equal to alpha because they are equal to each other according to the rule that I mentioned. So triangle ABD, the sum of the angles must be equal to 180 degrees. Alpha plus alpha, this is 2 alpha plus 80 degrees, must be equal to 180 degrees according to the rule that says that the sum of the angles in any triangle is equal to 180 degrees. So in triangle ABD, 2 alpha plus 80 degrees equals to 180 degrees. If we subtract 80 degrees from this equation, if I found out that 2 alpha equals to 180 degrees plus 80 degrees, it is 100 degrees. So if we divide this equation by 2, if I found out that the missing angle alpha equals to 100 degrees over 2, that is 50 degrees. Those two angles are both equal to alpha, therefore each of them is equal to 50 degrees in size. What is the size of this big angle, the size of this angle CBDC? Angle BDC equals to the big angle that is 80 degrees plus this angle that is 50 degrees. Again, the size of this angle is 80 degrees minus 80 degrees minus 50 degrees, that is 30 degrees. It is very easy to see it from the drawing. In the next step, we define this angle BCD as beta. And we implemented the law of sides in this triangle ABD. But again, we implemented the law of sides in this triangle ABD. So, a quick thinking on the law of sides. This is triangle ABC that could be any triangle. Side AB equals to C units in its left, side AC equals to B units in its left, side BC equals to A units in its left. In this, and we also know that the size of this angle BAC is capital A degrees. The size of this angle ACB equals to capital C degrees in its size. And the size of this angle ABC is equal to capital B degrees in its size. And according to the law of size, in this triangle ABC that could be any triangle, the following equation is 2. A over sinus A equals to B over sinus B equals to C over sinus C. Again, this triangle ABC that could be any triangle, the following equation is 2. A over sinus A equals to B over sinus B equals to C over sinus C. Again, A, capital B, capital C, the size of those three angles, triangle ABC. So we can actually implement the law of sides in our drawing. Because in our drawing, we implemented the law of sides in this triangle ABD. In this triangle ABD, according to the law of sides, BD over sinus 80 degrees equals to AB over sinus 50 degrees. Again, this triangle ABD, according to the law of sides, BD over sinus 80 degrees equals to BA over sinus 50 degrees. And again, triangle ABD, according to the law of sides, BD over sinus 80 degrees equals to AB over sinus 50 degrees. In the next step, we substitute 80 by 2 times 40, 80 degrees by 2 times 40 degrees, and we substitute 50 degrees by 90 degrees minus 40 degrees. So So we have BD over sinus 90 degrees. So sinus 90 degrees is sinus 2 times 40 degrees, and this is equal to AB. We defined AB SA, so because of the fact that AB equals to BC equals to AD, they are both equal to ABC CRX according to our definition. So AB equals to A, so we substitute AB in this equation by A or sinus 50 degrees. Again, 50 degrees is 90 degrees minus 40 degrees. So sinus 50 degrees equals to sinus 90 degrees minus 40 degrees. Here we have two trigonometric identities. The first trigonometric identity says that sinus 2 alpha equals to 2 times sinus alpha times cosine alpha. The second trigonometric identity says that sinus 90 degrees minus alpha equals to cosine alpha. According to this trigonometric identity, we will get that sinus 2 times 40 degrees equals to 2 times sinus 40 degrees times cosine 40 degrees. Again, sinus 2 times 40 degrees equals to 2 times sinus 40 degrees times cosine 40 degrees. Likewise, according to this trigonometric identity, we will get that sinus 90 degrees minus 40 degrees equals to cosine 40 degrees. So in total, we found out that BD over 2 times sinus 40 degrees times cosine 40 degrees equals to A over cosine 40 degrees. Here we have cosine 40 degrees both sides of the equation, so cosine 40 degrees will get cancelled. After cancel cosine 40 degrees, in this side of the equation we left only with A, while on the other side of the equation we left with BD over 2 times sinus 40 degrees. So in total, we found out that A equals to BD over 2 times sinus 40 degrees. Here, multiply this equation by 2 times sinus 40 degrees, and we found out that BD equals to 2A times sinus 40 degrees. This is the missing side BD is equals to 2A times sinus 40 degrees in its length. Again, BD equals to 2A times sinus 40 degrees in its length. In the next step, implemented the law of sines. This green triangle BCD. This green triangle BCD, according to the law of sines, BD over sinus beta equals to BC over sinus 40 degrees. Again, this green triangle BCD, according to the law of sines, BD over sinus beta equals to BC over sinus 40 degrees. The green triangle BCD, according to the law of sines, BD over sinus beta equals to BC over sinus 40 degrees. We already found out that BD equals to 2A times sinus beta, so BD by 2A times sinus 40 degrees over sinus beta, and it equals to BC. According to our definition, BC equals to A, so substitute BC by A over sinus 40 degrees. Sinus 40 degrees is 1/2. So total this is the equation, we have A over 1/2, A over 1/2 is 2A. So total we found out that 2A times sinus 40 degrees over sinus beta equals to 2A. Here multiply this equation again, 2A times sinus 40 degrees over sinus beta equals to 2A. Here we multiply this equation by sinus beta, and we found out that 2A sinus 40 degrees equals to 2A times sinus beta. And 2A sinus 40 degrees equals to 2A times sinus beta. Here we have 2A both sides of this equation, so 2A will get cancelled. After cancel 2A, we left only with sinus 40 degrees equals to sinus beta. Okay, again, we found out that sinus 40 degrees equals to sinus beta. If sinus 40 degrees equals to sinus beta, it means that beta equals to 40 degrees in its size. But we have another solution for beta. According to this trigonometric identity, sinus alpha equals to sinus 100 degrees minus alpha. So according to this trigonometric identity, we get that sinus 40 degrees equals to sinus 100 degrees minus 40 degrees. 100 degrees minus 40 degrees is 140 degrees. So in total, we actually found out that sinus 40 degrees equals to sinus 140 degrees. And therefore, here we can add to this equation that sinus 40 degrees equals to sinus 140 degrees. So sinus 40 degrees equals to sinus 140 degrees equals to sinus 40 degrees equals to sinus beta. And from this equation, sinus 140 degrees equals to sinus 40 degrees equals to sinus beta, we will get that sinus 140 degrees equals to sinus beta. Those two sides of the equation are equal to each other. So sinus 140 degrees equals to sinus beta. If sinus 140 degrees equals to sinus beta, it means that beta equals to 140 degrees in its size. So we have two possible solutions for the size of angle beta. Angle beta could be equal to either 140 degrees in its size or to 40 degrees. But because of the fact that from the drawing it's very easy to see that angle beta is definitely greater than 90 degrees. If angle beta greater than 90 degrees, angle beta can never be equal to 40 degrees, that is less than 90 degrees. So we can get this solution. We took into account only the second solution for angle beta, that angle beta equals to 140 degrees in its size. This angle beta is equal to 140 degrees in its size. So this is the LBCD. According to the rule that says that the sum of the angles in the triangle equals to 100 degrees, we get that 30 degrees plus 140 degrees plus the missing angle BCD plus the missing angle DBC total must be equal to 180 degrees according to the rule that I mentioned. So again, angle BCD, the sum of the angles must be equal to 180 degrees. That is to say, 30 degrees plus 140 degrees plus the third missing angle DBC total must be equal to 180 degrees. 30 degrees plus 140 degrees is 170 degrees plus the missing angle DBC total must be equal to 180 degrees. If we subtract 170 degrees from this equation, we find out that the missing angle DBC equals to 180 degrees minus 170 degrees is 10 degrees. This is the missing angle DBC that equals to 10 degrees in size. Our test is to find out the size of this angle ABC that equals to x. From the drawing it is very easy to see that angle ABC total equals to 50 degrees plus 10 degrees, it is 60 degrees. So actually found out that the missing angle ABC equals to x is equal to 60 degrees in size. So we finish the first method. In the next step I print on the solution of the second method. Actually, we finished with the first question. In the next step I print on the solution of the second question of both methods. The second question, our test was to find out the length of side AD is equals to x. Our test was to find out the length of this side AD for the other ABCD is equals to x. We have to find out the value of x. So first of all, we join points B and D together by straight line. By joining points B and D, we divided this quadrilateral ABCD into two parts. The first part is this right triangle ABD, and the second part it is this right lower triangle BCD. So in the next step, we implemented the Pythagoras theorem on both those two right triangles. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So first of all, we implemented the Pythagoras theorem on this right upper triangle, triangle ABD. According to the Pythagoras theorem, in this right triangle ABD, BD squared, that is the square of the hypotenuse, equals to AB squared plus AD squared. And again, in this upper right triangle ABD, according to the Pythagoras theorem, BD squared, that is the square of the hypotenuse, equals to AB squared plus AD squared. BD is the missing hypotenuse, so leave this as it is, and it equals to AB squared plus AD squared. But AD is x, therefore AD squared is x squared. So in total, if you found out that BD squared equals to AB squared plus x squared. This is according to equation 1. In the next step, we implemented the Pythagoras theorem on this right lower triangle, triangle DBC. The right lower triangle DBC, DB squared, that is the square of the hypotenuse, equals to BC squared plus CD squared. And again, the right lower triangle DBC, according to the Pythagoras theorem, DB squared, that is the square of the hypotenuse, equals to BC squared plus DC squared. So dB is the missing side, so leave it as it is. So it is dB squared equals to BC squared. BC is also the missing side, so leave it as it is. So dB squared equals to BC squared plus DC squared. DC in total it is 1 plus 4, that is 5. Therefore DC squared is 5 squared, that is 25. So in total, if you found out that dB squared equals to BC squared plus 25. So if we have two equations for dB squared. Therefore, we get that equation 3 that says that dB squared according to equation 1 must be equal to dB squared according to equation 2. Because again, according to equation 3 that we created, dB squared according to equation 1 must be equal to dB squared according to equation 2. dB squared according to equation 1 equals to AB squared plus x squared. And it must be equal to BD squared according to equation 2, this is equal to BC squared plus 25. So total according to equation 3, I should found out that AB squared plus x squared equals to BC squared plus 25. According to what is given in this equation, AB equals to BP, side AB equals to side BP. So the next step, implemented the Pythagoras theorem on this is a great lower triangle BCP. According to the Pythagoras theorem, in this right triangle BCP, BP squared, that is the square of the hypotenuse, equals to BC squared plus CP squared. The triangle BCP, according to the Pythagoras theorem, it is triangle BCP. According to the Pythagoras theorem, BP squared, that is the square of the hypotenuse, equals to BC squared plus PC squared. And again, because of the fact that AB equals to BP, therefore BP squared equals to AB squared. We substitute BP in this equation 4 by AB, because AB equals to BP. So BP squared is AB squared equals to BC squared plus PC squared. But PC is 4, therefore PC squared is 16. So total according to equation 4, we actually found out that AB squared equals to BC squared plus 16. This is according to equation 4. But according to equation 3, we actually found out that AB squared plus x squared equals to BC squared plus 25. According to equation 4, AB squared equals to BC squared plus 16. Therefore, we can substitute AB squared in this equation 3 by BC squared plus 16 from equation 4. We did it, and we got that AB squared equals to BC squared plus 16 plus x squared It is equal to BC squared plus 25. So here we have BC squared on both sides of this equation 3, so BC squared will get cancelled. After cancel BC squared, this side of the equation 3 we left only with 16 plus x squared, but on the other side of the equation we left only with 25. So in total we should found out that 16 plus x squared equals to 25. Here we subtracted 16 from this equation, and finally found out that according to equation 3, x squared equals to 25 plus 16 is 9, so x squared equals to 9. Here we took all the order of this equation, and finally found out that x equals to the square root of 9, that is 3. So according to the first method, the length of this line element AD equals to x is equal to 3 units. So the next step, I put on the solution according to the second method of this second question. In the second method, we extended side DC by 4 units. Again, we extended this side DC of this quadrilateral BCD by 4 units. And we defined the edge of the extended part. This point is point Q. So CQ equals to 4 according to our construction. Okay, because we extended DC by 4 units, therefore CQ equals to 4 according to our construction. DC is one side of quadrilateral BCD, therefore it is absolutely a straight line. We extend the straight line by straight line, the result DQ is also a straight line. So DQ is a straight line, so if you focus on the upper side of the straight line, DQ is point C. Here the sum of the areas must be equal to 180 degrees according to rule 3. Rule 3 said that the sum of the areas on one side of the straight line is equal to 180 degrees. So which angles we have at the upper side of the straight line DQ is point C? We have this angle that is a right angle according to what is given in the equation, plus this missing angle. Total the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore this missing angle must be equal to 90 degrees in size. In the next step we join points B and Q together by straight line. And we prove that those two right angles can go into each other according to side angle side rule. So why those two right angles can go into each other? First of all, those two sides are both equal to 4, and therefore they are equal to each other, according to our construction. In addition, those two angles are both equal to 90 degrees, and therefore they are equal to each other. And finally, BC is the common side that belongs to both angles, so we can write down that BC equals to itself is the common side that belongs to both angles. So if we prove that those two right angles, PBC and BCQ, they can go into each other according to side angle side rule. And again, we actually found out that the right angle PBC can win. This is the side can win to the right angle BC according to side angle side rule. And again, actually found out that those two sides and the angle that is included between those two sides in this triangle BPC are corresponding equal to those two sides, and the angle that is included between those two sides, this right angle BCQ, and therefore those two right angles can go into each other according to side against side rule. And from the fact that those two right angles can go into each other, we will write that BP equals to BQ. BP equals to BQ according to the rule that corresponding sides in right angles are equal to each other. Those two triangles can go into each other, and therefore their corresponding sides, that is to say BP and BQ, must be also equal to each other on their length. So BP equals to BQ. BP equals to BQ. Because of the fact that AB equals to BP, it means that AB equals to BP equals to BQ. So all those three sides are equal to each other in the length. AB equals to BP equals to BQ. So in the next step, we did the construction. This is to say, we do a circle around point B in such a way that point B will be the center of the circle, and AB will be the radius of the circle. Again, we do a circle around point B in such a way that point B will be the center of the circle, and BA will be the radius of the circle that we built. And because of the fact that AB equals to BP equals to BQ, all those three lines of the circle Let's really find this out. And because of the fact that those three line segments are all the radii of the circle, it means that the circle must pass points A, P, and Q. The circle must pass for point A, P, and Q. And is given as the equation that DA is perpendicular to AB. But AB is the radius. Therefore, DA is perpendicular to the radius AB. Therefore, DA is a tangent to this circle at point A. In the case because of the fact that according to what is given equation, DA is perpendicular to AB, and AB is the radius, it means that DA is a tangent to the circle at point A. DA is a tangent to this circle at point A. So if you focus on the convex standpoint point D, from the convex standpoint point D we have tangent DA, that is tangent to this circle at point A. In addition we have secant DQ, that cuts the circle at 2 points P and Q. Actually, dP is the external part of secant dq, and the secant in total equals to dq. So all the requirements of tangent secant theorem are satisfied, and therefore we can implement here tangent secant theorem in our drawing. According to the tangent secant theorem, the following equation is true if we focus on the convex point D, dA square, that is the length of the tangent squared, equals to dP times dq. Again, dA square equals to dP times dq. If you focus on the convex point D, according to the tangent secant theorem, dA squared, that is the length of the tangent squared, equals to dP times dq. dA equals to x, therefore dA squared equals to x squared, equals to dP is 1, times dq. dq in total equals to 1 plus 4 plus 4, that is 9. dq equals to 9. So it is, dP is 1, dq is 9, so x squared equals to 1 times 9, that is 9. X squared equals to 9, here we took out the equation, and finally found out that x equals to the square root of 9, that is 3. So if you found out that the length of this line segment AD equals to x, is equal to 3 units on both methods. Okay, thank you very much.